Hi, Assalamualaikum. So we are from Mechanical Engineering Laboratory 2, Group D5. So today we would like to present about the thermal stress analysis experiment. So before we start, I would like to introduce myself first, which is Muhammad Amzar bin Muhammad Noor, and my matrix number is 212963.
Okay, hi. My name is Ikhwan bin Ismail. My matrix number is 213087.
Okay, my name is Muhammad Khushaini bin Kamaruzaman. My matrix number 213141.
And my name is Muhammad Azrul bin Azmi with matrix number 213222.
Okay. So before we start, these are the contents that we have in this experiment, which are safety precaution. Second is details in the equipment. The third one is experiment methodology. The next is what are the results to be measured and recorded, and the last one is expected results. So before we proceed, I would like to explain first about the safety precautions. Next slide, please. First of all, we need to ensure that the lab is adequately ventilated to prevent the accumulation of heat or hazardous fume from equipment or samples. The second one, we need to always wear appropriate protective clothing such as lab coats, gloves, and goggles when handling biological samples and working with equipment that generates heat. Next, we need to ensure that all personnel involved in the thermal stress experiment are properly trained in laboratory safety procedures and understand the potential hazards associated with this type of experiment. And for the last one, we need to use specialized equipment design for thermal stress experiments, such as temperature-controlled incubators and heating or cooling devices to ensure that samples are exposed to the correct temperature in a controlled manner. So now we can proceed to other group member.
Thank you, Amzar, for the great explanation. Now I will continue with the next topic, which is the details of equipment that we use to conduct the experiment. First one is the power supply, where it is a critical component of any machines and electronic devices. Its primary function is to provide the necessary electrical power to operate the machine. Next is the temperature controller, where we are going to set the temperature first to 60 degrees Celsius in order to conduct our experiment successfully. Below the temperature controller is the heater switch, where its function is to simply turn on and off the switch. It is used to control the heating element of the machine, which is the heat source. Next is the selector switch, where it is used to change the setting up to 3 temperature data for each material. We change the setting if we want to read the data for other material as well. Above the selector is a temperature indicator, in which it shows the temperature for each material that we selected before by using the selector. Next, we move on to the upper side of the machine. The first one, we have 3-dial gauge. It is used as a pressure measurement. Each dial is connected to different types of material, so it measures the temperature of its respective material in the system. These readings can be used to determine if the pressure is within a desired range of, or if there are any pressure fluctuations that may indicate a problem. The last one is a heat source. The function of heat source is to provide thermal energy to a system or process. The primary purpose of a heat source is to raise the temperature of a material or substance to a desired level or to maintain a specific temperature range. That's all from me. Thank you.
Alright, so I will talk about the methodology and how to use for all the apparatus or equipments that involved in this experiment. Let's go. Okay, so for the first step, we need to switch on the apparatus power supply. Then, as we can see in this video, we need to set the 3-dial gauge reading to 0. All of this reading need to be recorded. After that, we need to record the initial temperature of each specimen by turning the selector to T1, T2, and T3. For your information, T1 is for stainless steel temperature, T2 is for copper temperature, and then the last one is T3 for the mild steel temperature. Next, to start this experiment, we need to switch on the heater. The next step is to set the temperature at the temperature controller to about 60 degrees Celsius. For your information, the green color one is the temperature that we need to set, and the red color shows that the actual temperature. Then, we need to start the stopwatch for about 10 minutes. After 10 minutes elapse, record down the 3 set temperature readings and the change of the length readings. For your information again, doesn't matter if the temperature exceeds 60 degrees Celsius. Then, we need to repeat this step to obtain 3 sets of results up to 15 minutes. While waiting for the experiment, we can compute the table given in the lab manual and then calculate the thermal expansion coefficient for all the specimens. And then, we need to compare the readings with the theoretical readings. After that, we can calculate the test specimen strain value and hence the thermal stress value. After we get the complete set of results from this experiment, we need to plot the graph of thermal stress against temperature differences. The more details about the expected result from this experiment and how to plot the graph, the next group members will be taught about it. Lastly, when everything is done, we need to turn off the heater, switch off the power supply, and switch off the main plug at the back. Alright, as I said earlier, the result to be measured or record and the expected result and also how to plot the graph will be taught by the next group member. So, I will pass the baton to them. Thank you.
Okay, next, we are going to move to what are the results to be measured and recorded. In this experiment, the results are divided into 2 different categories, where it is measured and recorded by the apparatus and calculated by the formula. Initial length and final length of each rod, which is denoted as L and L naught respectively. After change in temperature are recorded. The initial temperature of the rod and the final temperature of each rod, T naught and T were recorded. Next, there are a few results that should be calculated by formula, such as thermal expansion or alpha, which is the coefficient by the formula delta L over delta T times with L naught. Second is strain, where delta L over L naught. And the third one is the thermal stress, where the strain times with the coefficient for each material. And lastly, a change in temperature for each interval and change in length also for each interval.
Thank you, Ikhwan, for the explanation. So I would like to proceed with the expected results. So next slide, please. Basically, the expected result is what that we expect by doing the experiment. So for this thermal stress analysis experiment, it involves subjecting materials or structures to high temperatures to assess their thermal stability and mechanical properties. The expected results of thermal stress analysis experiment will depend on the specific research question being investigated and the type of materials or structures being used. Therefore, the thermal stress can cause changes in the mechanical and physical properties of materials, such as tensile strength, ductility, and hardness. Researchers may expect to see changes in the material properties that are directly related to the thermal stress applied. For the next one is, the high temperature exposure can lead to permanent deformation or failure of the material or structure being tested. There may be changes in the shape or integrity of the sample during or after the experiment. Next. For the third one, the thermal stress analysis experiments can provide information on the thermal conductivity of materials or structures. We may expect to see changes in the thermal conductivity that are directly related to the temperature and duration of the thermal stress applied. For the last one, the high temperature exposure can cause changes in the microstructure of materials. such as changes in the grain size or orientation. To conclude everything, the specific result of thermal stress analysis experiment will depend on the experimental design, the duration and intensity of the thermal stress, and the type of materials or structures being used. It is important to carefully plan and execute thermal stress analysis experiments to ensure that meaningful results are obtained.
Lastly, we are going to learn how to plot the graph. First of all, we have to identify the y-axis and the x-axis. Y-axis is defined as the thermal stress, while the x-axis is the temperature difference for each interval. Okay, the data is taken back from the result that we obtained and the result that we calculated. Thermal stress is in megapascal, and the temperature difference in Kelvin. We plot the graph in a line graph for each materials, such as stainless steel, copper, and mild steel. I think that's all from us. Thank you.